Hello and welcome to this paper. I'll be presenting From Mental Networks to Virtualization by Avatars, a first software implementation. I'm Frank de Jong and I'll be doing the presentation. Simulating human mental processes has been the subject of much research in the past decade. These simulations use computational causal models based on causal pathways in the brain and body. Causal models can be adapted to fit natural mental processes and specific human traits. From simulations by such models, virtual agents based on avatars can be created, which express the generated patterns of mental states over time. This approach can be used in coaching or therapy sessions as a way for people to understand their functioning better. Since this is all virtual, the scenarios can be flexible and convey complicated behaviors involving multiple people. Moreover, these virtual agents can also be used in games or education. They can help provide insight into human mental processes. This paper focuses on such virtualization by digital avatars, how they are created, and how they can be applied to causal models to express human-like patterns and underlying traits. An approach is explored which uses existing software to build virtual agents based on avatars and causal models. The main software for virtualization is a Unity software. As an illustrative example, two avatars are created and imported as assets into a Unity project. Libraries were built that allow the avatar to be controlled for a wide variety of potential applications. The methodology is based on adaptive mental causal network models and avatars expressing their simulation. The shared mental networks used for mental processes is a basic similarity between natural humans and the obtained artificial humans. Many people suffer from a lack of mental well-being. It is generally better to understand the causal patterns and pathways behind mental well-being to improve one's mental well-being. For a number of reasons, this is not always easy. Our educational system makes little systematic effort to help and to teach about mental well-being and underlying mental and neural processes. Traditionally, little time is reserved for learning about your own psychology and mental well-being. In media that are about mental problems, often unrealistic simplifications are presented in order to make it not too difficult for the broad and diverse audience to follow it, for example in TV programs. There's a widespread idea that mental processes are what you are aware of, while in reality, much of our mental processing is unconscious. Therefore, it is completely ignored if the focus is only on what someone is aware of. This limitation easily leads to proposing naive and unrealistic solutions to mental problems. For example, saying, just exert more willpower to change undesired conscious patterns. There is a traditional medical view on problems based on linear, non-cyclical causal pathways. To get rid of undesired symptoms, simply the cause has to be taken away. This is akin to simply removing a faulty part in your car. Often mental processes and problems involve cyclical and adaptive patterns that are much harder to imagine and understand than this traditional medical view. Therefore, for many people, improving their mental well-being is a very demanding matter. It requires understanding of their own mental capabilities and then further understanding to take steps to improve mental well-being. As a result, it is difficult to improve their suboptimal mental well-being, and as a consequence, they may just continue to suffer from that their entire life. This can be even more difficult for individuals that have limited opportunities for intellectual and linguistic development. This situation for mental well-being, in a metaphorical sense, can be considered a specific illiteracy issue. But often, even in therapeutical context, there is usually a strong emphasis on language. For counselors or therapists within a therapeutical context, a main issue is often how to address and resolve this type of illiteracy. And often, since they're mainly verbal, therapies will work much better for clients without such illiteracy, or having the capability to resolve it relatively easily. In contrast, therapies are usually much more difficult, for example for young children or immigrants, or other persons who are not able to interpret and use the applied language well. To overcome such illiteracy, a fundamental starting point is to consider the issue from an educational and pedagogical perspective. To achieve better mental well-being, it is needed that better knowledge, awareness, and skill concerning mental well-being are developed. This parallels the idea of Paulo Freire developed concerning his pedagogical literacy method, where illiterate individuals he combines learning to use language with getting them more aware of their own situation. He found himself in a situation with many people both illiterate and without much awareness of their often difficult situation in society. This has some parallels with the situation concerning mental well-being. In the case considered here, individuals are lacking more sophisticated knowledge about mental processes and language to describe them. And on the other hand, they often suffer from suboptimal mental well-being in their own situation. To develop learning material according to Freire's method, the developer codifies a number of conflicting or problematic situations from the learner's context, to which they can empathize. This could be in the form of pictures to which the learners can feel related to. During the learning process, decodification takes place. Learners empathetically feel, recognize, and analyze what is in such picture and behind it. This makes them more aware of this situation, and this is called critical consciousness by Freire. While they develop conceptualizations of it, including the language to express themselves. The methodology presented has parallels to Freire's method. Here the aim are to make the persons more aware of their own mental well-being and underlying mental and neural processes. This makes them feel more related to them and can develop better conceptualizations and language for them. The notion of codification has a parallel in the virtualization of these processes that is part of the method presented here. And the deed of codification is what happens when a person learns from interacting with these virtualizations. The difference is that in his time, Freire often used pictures as codifications, while now, in 2021, we aim for using movie and game-like means for similar purposes, although pictures and cartoon-like formats are not excluded. Based on the considerations, the project called COSI-Human, for Cooperative Simulated Human, is undertaken on causal modeling, simulation, and virtualization of mental processes, therapy, and coaching sessions. The overall goals is to explore the possibilities for causal modeling and simulations of mental processes, including therapy and coaching sessions. How the simulations can be virtualized by avatars to obtain virtual bots expressing mental and physical states over time. How the obtained virtual bots can be useful in joint therapy and coaching sessions, for example by showing specific mental processes and serving as a kind of familiar supportive partner. In the figure, the main steps are indicated. The step labeled studying is taking place by many researchers within neuroscience and related areas, and has led and is still leading to a more and more impressive portfolio of scientific papers. For certain choices of case studies, this can provide the underlying knowledge. The second step, labeled modeling, concerns the design of computational models to simulate the type of mental processes considered. The third step, labeled by virtualizing, uses the patterns generated by the simulations to give them a human-like appearance using human-like avatars. Finally, the fourth step, labeled by interacting, concerns the learning situation in which the natural human learner learns from the artificial human and perhaps conversely. In a network-oriented modeling approach based on temporal causal networks described by Treur, a network structure is defined by a network characteristics for connectivity, aggregation, and timing. Network nodes have activation values that change over time. They serve as a static variable and, like in philosophy of mind, are also called mental states. Such states are depicted in the slide by the small ovals and the causal relationship between them, the connections in the causal network, by arrows. As an example, consider a couple therapy for partners A and B, where partner A has aggression issues and being in control issues. For example, the following script can be generated by the causal models for emotions and emotion regulation. The aim for using a virtualized version of this script can be for the couple to gain insight in interaction patterns related to anger and fear regulation. So the script might be person A shows some level of anger and has no emotion regulation. Person B observing this gets a stressful emotion and therefore looks away in order to regulate this fear emotion. Now person A observing this person B looking away shows even more anger and makes some threatening gesture. This causes person B to get a stronger stressful emotion and walk out of the room. Now person A shows even more anger and eventually breaks something valuable in the room. These are the interaction processes that can be well modeled by a causal modeling approach, where person A has poor anger emotion regulation incorporated together with a dependency on feeling fully in control of situations, and person B well functioning, but for A undesirable, emotion regulation based on attentional deployment and situational modification. This is also shown in the graph here. Now, the setup for the software environments for virtualization. Some basic requirements for the avatars are set. The avatars must express 6 basic emotions: anger, disgust, fear, happiness, sadness, and surprise, from Ekman's theory of basic emotions. This project focused on the initial basic emotions due to the scope of the research, but left the door open for more emotions to be implemented and integrated easily. From Ekman's Unmasking the Face, emotions can be encoded using the facial action coding system, developed by Ekman, Hager, and Friesen. Furthermore, the avatars must be able to run, walk, strafe, and turn. The project should be able to be expanded to support even more complex virtual behaviors. Now, the creation of Avatar utilizes the Make Human project, Blender, Mixamo, and Unity. The Make Human application is an open source tool designed to simplify the creation of virtual humans using a graphical user interface. This software is ideal since it abstracts the complexity of 3D modeling and allows for creation of realistic, virtual, human-like avatars. Realistic and relatable looking avatars are essential, given a higher level of empathy can be attained based on the appearance and similarity to an avatar. The creation of the avatar is very straightforward, with sliders for the avatar's visual features, for example, gender, age, weight, height, race. And the project has many plugins that allow additional features and customizations to be added. Here is an image of the Make Human GUI. Next, the Blender software is an open source 3D creation suite, and it supports the entire 3D pipeline, including allowing the avatar to be animated, modeled, rendered, and many other features. The avatar creation uses a feature called Blend Shapes, which enables the shape, in this case the mesh of the avatar, to be deformed into a new shape, and gradually by scaling and transforming or rotating its vertices. This feature allows the avatar to express emotions. The Unity game engine, or Unity software, is the final software used in the project. The avatar can be programmed to express human traits in the engine. The data is used to express the human traits is collected from the simulation data from the causal models, and a library is added to read them. Unity takes care of all parts of the virtualization, from rendering the avatar's world creation, controlling the camera's sound, and any other component used to show the avatars. Unity is also a very powerful engine because it supports almost any platform easily. And in the scope of this project, it allows for easy cross-platform access to virtualized avatars. The example causal mental network model provides several expression states which are addressed by the virtualization. In this scenario, they correspond to person A's anger, person B's threatening, person B's gaze away, person A's threatening, person B's gaze away, and person B's walk away. Inside the Unity project, for each virtualization, a new scene is created. The first part that must be created is the environment in which the avatars are placed. This process can be extensive and tailored specifically to the model. This is, however, skipped because it's very time-consuming. Therefore, a simple floor is created with the 2 avatars placed facing each other. A few lights and cameras are added, and these are required to render the avatars. The next step is to create a virtualization script. Here the simulation data is read, and the avatars are controlled with the read data. The actions for each avatar needs to be implemented, since these can be specific to the model. In this example, a couple of activities are performed by avatar B, namely the look away and walk away. Therefore, the two actions need to be created, a gaze away action and a walk away action. The implementation of these actions have access to the avatar's components, which enables anything to be modified. The components implemented for each avatar are an emotion controller, allowing the avatar's emotions to be set, an eye movement controller, allowing the avatar's eye position to be set, and finally, a set of actions. These actions can be programmed to make the avatar perform certain movements or animations. In the case of a walk-away action, an avatar's animations can be controlled and their movements set so that they're walking away, as shown in the slide as well. An action can also control the emotion or eye movement controller as well. So essentially a set of complex behaviors can be implemented in a single action, which involves multiple components of the avatar. The diagram shows the components of the virtualization. The green boxes are properties that are present for all avatars, while the black boxes are components that are implemented for each mental network model. In the example of the simulation data, the virtualization scripts, camera controller, scene, and the two avatar actions are created. Those are shown by the black boxes. The virtualization script should create a step function where each row in the simulation data is read and applied to the corresponding action of the avatars. In this example, 3 values in a row are applied. The avatar A's anger, a value between 0 and 1, which represents the intensity of the anger emotion. This value is virtualized by accessing the avatar's emotion controller and setting the anger emotion to the intensity. Next, avatar B's walk away, also a value between 0 and 1 is applied. Once this value is larger than 0.5, the action is triggered and the avatar walks away. A simple check is added in the step function, and once the condition becomes true, the action is initialized. The gaze away value is very similar to the anger value. In each step, the gaze away action is set to the value representing the intensity. A gaze away value of 0 means the avatar is not looking away at all, while a value of 1 means that they are entirely looking away. The step function is triggered once every 200 milliseconds, and the step function is repeated until all the simulation data has been applied. Additionally, the script may also activate certain cameras during the virtualization. So to conclude, the project shows that making these avatars is possible and applying them to simulation data works. The dynamic avatars can act out several behaviors in many different scenarios. Since the software used allows for a lot of customization, creating new and different looking avatars is straightforward, albeit additional tools must be developed to make this less time consuming. Building the project further is straightforward as a lot of documentation is provided, but the 2 avatars already created can also be applied to different models. One of the goals was to make it easy for the project to be expanded, and laying out the creation process should allow for easy adaptation. Since so many of the different software was used so many different software was used for the avatar virtualization, any part can be modified and changed. If more emotions are needed or existing emotions need to be modified, the changes can be performed in Make Human, while the remaining export process remains the same. However, creating avatars is not yet as easy because it's very time consuming. After the initial avatar is created in Make Human, the facial expressions must be applied and exported. This process is very repetitive and provides an ideal opportunity for automation. This automation dramatically would improve the flexibility of the virtualization project, as the creation of the avatar is very easy when already existing a GUI. Furthermore, a focus was on exploring the possibility of virtualization. Fortunately, the Unity game engine allows for a vast amount of graphical features to be changed or set. Making the environment feel more authentic will be essential. Furthermore, making the avatars behave more human-like is something that can be improved. More natural features can be added, like blinking at random intervals or turning the head slightly every once in a while to make the avatar less robotic. Additionally, several libraries were created to make controlling the virtual avatar easy. These include the emotion controller, eye movement controller, and the avatar action library. Each component is responsible for making it easy to set the properties of the avatar. Setting emotions, moving the eyes, and triggering actions are easy to use by extracting the complex implementation. These libraries can be built and expanded on with relative ease. Overall, the aim of the project to create virtual avatars was accomplished. The avatars were also applied to simulation data from the causal model, showing that it can work. This was further supported by the two experienced software developers from industry who evaluated the project. They provided very positive feedback and described the project as well documented and ready to be expanded in the future. Furthermore, several other future prospects came into view, automating avatar creation, additionally realism features, and making the avatars more human-like. Along with this, allowing bidirectional interaction between humans and avatars also becomes a possibility. In therapy, as a role-playing tool, humans can interact with the avatars not just by observing, but by making choices on the fly. This interaction can be in choosing a different emotion regulation method, which in turn causes the avatar to behave differently. Selecting a different emotion regulation method is particularly useful to show how other behaviors changes the avatar's actions. Furthermore, the possibilities for expanding the project are virtually endless, and applications to the real world are extensive. Thank you for listening to the presentation.